Hello everyone, and thank you for attending today's webinar, Integration Challenges of Software-Defined and Virtualized Enterprise Networking, sponsored by Equinox. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up by email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. At the end of the webinar, we'll ask you for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to our moderator, Heavy Reading Senior Analyst, James Crawshaw.
Thanks, Becky. Hello and welcome everybody to this light reading webinar about the integration challenges of software-defined and virtualized enterprise networking, sponsored by Equinox. As Becky said, my name is James Crawshaw and I'm an analyst with Heavy Reading. I'll be moderating today and also presenting some material from an upcoming white paper. And with me to present is Praveen Mirchandani, Chief Marketing Officer with Equinox. Praveen, can you tell us a little bit about yourself and your organization?
Yeah, thank you very much, James. So, good day, everybody, depending on your time zone. Good morning or good afternoon. As James said, Praveen Mirchandani with Equinox. Some of you may know us under the brand name OneAccess. Equinox recently bought OneAccess, so that's just a check for you that are unfamiliar with the name Equinox. And my role at Equinox is to look after our access portfolio. And in particular, I've had a heavy focus on defining and elaborating our virtualization strategy going forward. And some of the results of that will be what I will be talking with James about during the course of this webinar.
Great. Okay, thank you. So the agenda for today, I'll be starting with a brief introduction and then we'll dig into some of the challenges of software-defined and virtualized enterprise networking. We'll look in particular at the interoperability challenge, integration, some technical challenges, and the organizational aspects that are affected as well. And we'll also discuss the need for VNF testing. As always, we aim to leave around 15 minutes or so at the end for audience Q&A. So please do submit your questions as we go through the webinar, and Praveen and I will do our best to try and answer them. So, historically, enterprise network deployments have been fairly static. The network has been made up of proprietary hardware, running proprietary software. You might have provisioned these network devices using command line interface or perhaps with a bit of simple scripting. And that sort of fairly static setup can lead to actually quite a complex and inflexible network, which isn't just expensive to buy, but it's also expensive to manage on an ongoing basis. Now, just as they have done in data center networking, SDN and NFV should be able to bring automation, agility, and a lower total cost of ownership to enterprise networking. NFV has matured now so that most enterprise network functions, here I'm thinking of things like routing, firewall, etc., can be hosted on x86 architecture-based servers. So instead of deploying lots of different dedicated hardware devices at the customer premise for each branch office function, operators now are looking to deploy a universal customer premises equipment that can deliver a variety of network functions on a single appliance. And with the next slide, Praveen's going to talk through the basic architecture of what that appliance might look like. Praveen?
Yes, James, thank you. So what you can see on this diagram is a schematic view of what a universal CPE would look like. So clearly it's got a common compute platform, and depending on the type and number of virtualized network functions that run on it, it will be spec'd in different ways. So clearly an x86 processor, together with some interface ports, WAN and LAN, but in particular the RAM and storage will vary depending on the nature of the VNF. So for instance, some VNFs such as WAN optimization require the ability to store data on the device, whereas others don't require that. And RAM also can vary depending on the VNFs that are running there. Turning towards the x86 processor, this can come with a number of cores, and again this depends on the type, i.e. how heavy the VNF is, and again the number of VNFs. So on top of the hardware we have a virtualized infrastructure managed, which is typically made up of open source components. So a distribution of Linux with virtualized networking components. So these can be things like a switch component, the open virtual switch that we can see here, maybe some acceleration mechanisms such as DPDK and others. Together with that there'll be hypervisor and as well as some management components. Typically these management components can be accessed using the netconf protocol, but quite often you'll see other means of accessing the white box, such as CLI or a GUI. And then on top of the virtualized infrastructure manager, there will be the individual VNFs themselves. So I've shown a couple here, vRouter, SD-WAN, firewall, but there are many others that could go on here, such as a session border controller, WAN optimization controller, caching, NAT, many other types of functions could be hosted on this universal CPE.
Great. Okay. So as we showed on that previous slide, SD-WAN is a popular application that we might run on a universal CPE. SD-WAN, we find, is helping businesses to reduce their connectivity costs and also to make their services more agile. What we're showing on the screen now are some survey results that show what the sort of the key attractions are for SD-WAN. And it's lower costs, it's faster deployments, it's the ability to integrate multiple functions onto one device. Those are seen as some of the key attractions of the SD-WAN propositions that are out in the market. Now, until recently, a lot of enterprises were happy just to deploy another dedicated appliance for SD-WAN, but actually now they're increasingly looking to deploy SD-WAN as a function, as an application, running alongside others on that sort of universal CPE device that we showed the basic architecture of on the previous slide. So SD-WAN becomes a component of a function rather than a box on its own. So our survey results explained, I think, some of the attractions of SD-WAN from the perspective of the enterprise, but what's in it for the operator? We do hear that SD-WAN is potentially going to cannibalize existing services for branch connectivity, things like MPLS. In essence, what's driving the SD-WAN business case, if you like, for the operators is competition. In the US, for example, cable operators see SD-WAN as a great opportunity to get into enterprise services outside of their existing footprint. And naturally their existing footprint is targeted mainly the residential community. It might not be in the right locations for business parks, etc. So the incumbent enterprise service providers are now having to respond to these competitive threats from the cable operators by having their own SD-WAN offerings in order to remain competitive. At the same time, some enterprises are looking to deploy SD-WAN on a sort of do-it-yourself basis. They buy basic internet access services to connect their sites, their branches, and then they'll buy the CPE devices that come from an SD-WAN vendor in order to implement the SD-WAN solution. That sort of do-it-yourself approach obviously is a big threat to managed service providers, and so again they're forced through these competitive forces to add SD-WAN to their existing connectivity offers in order to avoid losing out on valuable customers. So this is our first audience question poll for the day. We're asking, which approach is your organization taking to SD-WAN deployments? Obviously this question is oriented at the service providers, so if you're not a service provider, you can skip this one. Would you say that you've chosen a couple of vendors and you offer their hardware-based solution to your enterprise customers? Would you say that you've deployed a universal CPE on which you plan to offer security and other value-added services in addition to the core SD-WAN offering? Or are you still thinking about this, still evaluating the different options? Whilst you have a think about your answer to that, just remind everybody that we do have 15 minutes at the end for audience Q&A. So as we go through the webinar, if you think of any questions for Praveen or for me, please do type them in. Okay, let's see what the results have been for that question. So the vast majority, slightly over 80%, still evaluating their options. But of those that have taken an initial decision, it seems to be that the UCPE is the favoured approach. Is that a surprise to you, Praveen? Not, I guess, that so many people are evaluating their options, because that's going to be the kind of audience we'll attract to a webinar like this. But of those that have made a choice, quite a strong proportion of those have adopted the UCPE approach. Is that what you tend to see in the market, or less so?
I think it really depends on who you're asking. I saw a similar question at a WAN summit that I attended in London recently in the UK. And the responses were quite different, actually, whereas 50% of people had fairly active plans to deploy SD-WAN. To some extent, it was a self-selecting audience because they were attending an SD-WAN summit, so you would expect that. But I think, if I look at the the operator community, and I guess there are many operators on this webinar, I do feel that many are still evaluating their options. So given the audience profile, I'm not that surprised. But as I said, if it was more of an enterprise audience, I think I would see different results. More people that were more actively looking at it, and perhaps a more even spread between bare metal servers or individual appliances and UCPE.
Okay. Great. Okay, so interoperability and integration challenges. So to serve this very nascent SD-WAN opportunity and the broader opportunity that NFE brings, service providers are often going to market with a couple of different universal CPE platforms, also going with a couple of different SD-WAN offerings, and perhaps more than a few different security partners. But even when they try to restrict the number of options available, service providers typically find it quite a challenge to integrate all of those different combinations of SD-WAN, firewall, and other VNFs with their chosen universal CPE. VNF interoperability is a major challenge that comes from this problem of disaggregating the network management system software from the operating software and the underlying hardware. With physical infrastructure, that all came pre-integrated, but now with virtualization, the operator has got the fun job of gluing it all together themselves. For every new VNF, a service provider may need to make actually some pretty big investments in tooling to integrate with the VNF vendors' systems in order to give a single pane of glass for the enterprise customer that will cover monitoring, ticketing, and performance and capacity management. The quick fix, of course, to all of this is just to take a turnkey solution from one vendor, but that's then leading you into a sort of vendor lock-in situation, which undermines a big part of the business case that was behind virtualization in the first place. So instead, operators that pursue a multi-vendor strategy are going to need to do some pretty thorough testing to ensure that the correct VNF instantiation, configuration, and service chaining is all in place. On top of that, they'll need to test the integration of VNFs with northbound management systems to ensure that the deployment can be automated. So for the next slide, I'm going to hand over to Praveen to go into a bit more detail about some of the technical challenges.
Yeah, I mean, I think one thing to bear in mind is that many VNF vendors have different backgrounds, and quite often it's an appliance background. So they've really been in control of the hardware environment and obviously the management and control environment for their appliance. But as they look to enter into the NFV environment, they're often confronted with a number of problems. I mean, one is taking that software that they've had on their hardware appliance and making it open and able to chain with different types of other VNS from other vendors. Our experience, and we've been involved in quite a lot of live deployments now, as well as multiple trials at service providers around the world, has been that there's quite a few integration challenges that have to be worked through. One of the key issues is the API, so that the management system that actually drives the VNFs, sometimes that API is not as complete as you would expect. So it means that some of the features and functions of the former appliance, or now the virtualized network function, are not fully available. There's also the issue of zero-day deployment, where typically the management system or controller will need to provide some specific types of information to the VNF to make it or to bring it up and ready to be able to run in that environment. So these things could be, the IP address, for instance, maybe some scripts to turn on some specific types of features and functions in the VNF, enabled to allow it to run. And that can often be a challenge because, again, the background of the VNF vendor may not be able to facilitate that in the sort of open environment that is expected of a virtualized deployment on a UCPE. Quite often we find other problems, such as documentation about how to deploy in the specific environment is either not available or is not as mature as you would expect it to be. And again, troubleshooting tools and log and alarm information may not be as easily accessible as would be required. That's just some of the problems that we have seen, when we onboard VNFs from different vendors. And then again, there is the issue of how to chain them, but I'll talk about that in a couple of minutes.
Okay, thanks, Praveen. So, continuing the theme of technical challenges, x86-based server technology has been able to run network functions like routing and firewall security for some time, but until recently the performance wasn't quite up to what you would get with more specialized devices like ASICs or FPGAs. The basic method for virtual networking in Linux is called a bridge, and this sits between the host operating system, the Linux kernel, and the hypervisor, for example, KVM. Now, Open vSwitch was developed as an alternative to that Linux bridge for hardware virtualization environments, and OVS, as it's abbreviated, gives you more functionality than that basic Linux bridge. It enables you to support things like VXLAN, GRE, and more granular traffic policy. But all of that comes at the cost of lower performance because you've got more processing required for all of that, those features and functions. Now, to try and get around that trade-off, Intel developed the data plane development kit, which essentially uses some special libraries that they designed in order to accelerate packet processing on x86-based hardware. Another innovation is single root I/O virtualization. That enables even better virtual switching performance than Open vSwitch. The downside, though, with SRIOV is that the VNF can't easily be moved to another server. It's tied directly to a particular hardware resource. As a result, SRIOV, it's not great for a sort of dynamic NFV environment in a data center where your VNFs might be moving between different servers all the time. But in a use case like enterprise CPE, where the application is always going to be running on the same the same server, then this isn't an issue. So while the benefits of SRIOV over basic OVS seem pretty clear, operators have found in practice that not all VNFs support SRIOV, and then that can mean that the throughput of the VNF is lower than what they had anticipated. It's not just networking functions that can struggle to work well on universal CPE. Another example in terms of OS dependency was a cybersecurity solution that had been designed to run on a Windows server and became very resource hungry when they tried running it using the KVM hypervisor on Linux. There are similar issues with CPU dependency. Some VNF components might require CPUs that support particular features that are only available on certain Intel CPU families, and as a result, those VNFs might not perform as expected on a universal CPE that uses a processor type that lacks those features. That brings us to our second audience question poll for the day. Which hardware acceleration technologies do you plan to use in your NFV deployments? So you can tick as many of these as you like. And obviously this question can apply to all participants on the webinar, whether you're a vendor or an operator or a systems integrator. You'll all, I'm sure, have some experience and something to say on this. So the options there: Open vSwitch, DPDK, SRIOV, Virtio, FDIO, PCI pass-through. We didn't talk about the last three, but there are other examples of hardware acceleration. So which of these, if any, do you plan to use in your NFV deployments? Whilst you click away, just remind everybody that the last 15 minutes or so of today's webinar will be for questions for Praveen and me. So as we go through the presentation, if you have any questions, please type them into the widget on the console. Okay, let's see what people have voted for. We've got some votes for all categories, but there's clearly more popularity with OVS than there is with things like VirtIO and FDIO. But Praveen, any observations from this? It seems as though both DPDK and SRIOV are almost as equally popular as the basic Open vSwitch. Anything there that caught your eye?
To be honest, I'm quite surprised to see that Open vSwitch is the leading acceleration technology being used. I have to say that our experience of using Open vSwitch has not been that great, as I think was shown in your chart. Typically, we find that SRIOV delivers the best performance. Again, I guess it depends on the environment that we're using here. So if it's a UCPE, then as you mentioned, SRIOV can make a lot of sense. Whereas in a sort of data center environment, you may need the flexibility that Open vSwitch can give you. But that would be my observation.
Good point. Yeah, fair point. Good point. Okay. So we said we were going to talk about the need for VNF testing. I think you're going to take us through this slide, Praveen.
Yeah, so as James has explained, there's a number of challenges, and again, I talked about integration. So what we have done has been to sort of try and break down the validation process into a number of discrete steps. So one of which is manageability. How do we instantiate the VNF? How can we pass information to the VNF? How do we zero-touch or zero-day provision it? Typically, we're using a process called Cloud Init to do that. Another thing that we assess is scalability. Typically, this will be scalability in terms of performance, but may also include number of sessions that can be performed by the VNF. Again, to a certain extent, it depends on the type of function that's being delivered there. The next step is functionality. Clearly, one can read the functionality on the data sheet, but as I said, sometimes not all of the functionality is accessible from the management system. So that's a key thing that we assess, is to what extent can we open up and deliver the functionality that's promised by the VNF from the management system. Ability talks to, obviously the various mechanisms that can be used to pass data from one VNF to another. Again, when we're looking at chainability, we may be looking at, what is the optimum position in the chain for the specific VNF. And again, this could depend to a certain extent on the use cases that are being delivered. Upgradability, obviously we're still, as an industry, at a relatively immature stage in the deployment of VNFs. One of the consequences of that is that versions come out fairly quickly as people begin to acquire knowledge, begin to acquire experience, and start to be confronted with different use cases. So we find that quite often we're getting monthly, if not weekly, upgrades to the VNFs. I'm sure that will stabilize over time, but as I said, we're still at a relatively early stage. And again, it's a key point. How do we upgrade the VNF, insert it back into a chain without degrading user performance? And that's a key thing, or disrupt user performance. Data plane performance, we talked about that a little bit. There are different mechanisms that we need to assess there. Also, performance is often intimately linked with the resources that are available, so the number of cores that are required to deliver a specific set of performances, as well as the amount of memory, and in some cases, the amount of storage that is required. As I mentioned before, WAN optimization is one of the key functions that does actually require onboard storage, but not the only one. And then something that we're seeing quite a lot at the moment is the performance on different types of x86-based hardware. Intel is in the process of migrating its Atom-based family from the C2000 family to the C3000 family. And as this is the cost-performant part of its portfolio, there's a high degree of interest in the Denverton family in terms of the performance it can deliver and different acceleration mechanisms that are available to it. But it does have slightly different instruction sets in order to get access to some of those acceleration mechanisms. So what we're finding now is that some VNFs that would perhaps work quite well on the Atom C2000 processor or on a ZND or ZNE processor do struggle on the Denverton processor, or sometimes don't work at all. So that's another thing that we look at quite closely when we're validating VNFs.
Okay, interesting. Well, in addition to testing the individual VNFs, you also need to test the VNFs in combination, the service chains. So the service chain is defined in a network service descriptor, which also describes the specific VNFs that you're using, their interfaces, and the embedded services that they provide. And creating these network service descriptors actually requires a significant amount of expertise and a lot of time analyzing the VNF documentation. To chain two VNFs running on separate virtual machines, you actually require a virtual network to combine them, and there are many options for creating that virtual network, although, as we've already discussed, not all VNFs will support them. So, for example, We talked about the virtual network potentially just relying on OVS, but even with OVS, there are two options: OVS with VirtIO interfaces or OVS with DPDK interfaces. And then with that latter option, there are further sub-options. You can have DPDK with single queue per interface or multi-queue. So whichever permutation you decide on for your particular service chain, it's got to be supported by all of the VNFs in that chain. Now, an overview of what a validation setup might look like is shown here in this diagram. In these tests, customer A and customer B each have their own universal CPE. They also share a third virtual CPE device, which is sitting in a service provider data center, providing services locally, but physically it's located elsewhere, not on the customer premise. All three devices here are connected via both an internet connection and a dedicated MPLS circuit, and each CPE runs its own SD-WAN instance that's controlled by an SD-WAN orchestrator. So putting that all together, making sure it all works, that's part of the testing that needs to go in before you're able to successfully deploy these services. Next up, we're going to pass back to Praveen to talk about the impact of disaggregation.
Okay, well, one of the major premises of virtualization is the ability to A, abstract the software from the hardware, so it can run on a common compute platform, B, to centralize the management in order to A, reduce costs, and B, increase flexibility for the person operating the network functions, and thirdly, to run on that same compute platform a number of different instances of VNFs. What it means, though, is that you have a lot of different components that are required to build a system that typically will often come from different vendors, particularly if you want a multi-vendor environment. And this means that when you look at this environment, there's quite a lot of different test points that need to be considered in order to make sure that all works well and can function as originally envisaged. So there's obviously, the linkage of the orchestrator to the existing IT or OSS system of the operator. The portal will need to be linked into the same systems, and that portal typically provides choices to an end user to rapidly instantiate sites in the case of SD-WAN, or distribute policy in the case of the SAME or firewall. And here we see often that the operators prefer to develop this portal in-house because it's a customer-facing component that they would like to have control of. But then again, in terms of time to market, it may be better to use a vendor's portal. And again, it may come down to resources. Then below the orchestrator will sit typically the controller that is used to deliver policy and instantiation to the individual VNFs. This again has to interface with the orchestrator and then interface down into the VNFs. And each vendor, if there are a multiplicity of different vendors, VNFs on the UCPE will have its individual controller. So there needs to be a single pane of glass to be able to integrate all of this. We've talked already about multiple VNFs in a service chain. And again, quite often we find that the hardware may be different. We've seen quite a marked difference in stance between operators. There are some operators that like to have control over the choice of the hardware, and so they may even buy the hardware itself and then look to put the virtualization infrastructure on top of it, perhaps from a different vendor, or some would prefer to buy that as a sort of prepackaged component from one or more vendors. So there's quite a lot going on here in terms of disaggregation. But as I said, and this is really speaks to the key part of this presentation, this really poses a lot of integration challenges. So going on to the next slide. Let's take a look at some of the checkpoints that we need to look at. I've already mentioned the completeness of the REST API. So if you have an existing OSS BSS or an existing orchestration system, you need to be able to access all of the individual features and functions of the VNFs. Obviously, if you're instantiating multiple VNFs, then there is how do you create the network service descriptor that describes the different VNFs, the resources that they require, the chaining mechanisms that are used to communicate between the VNFs, pinning, for instance, specific cores to a particular VNF to ensure certain types of performance. So there's quite a lot that needs to be looked at there. And in terms of the complexity of how you describe that and the tools that are available to so do. Then looking down at the hardware itself, VNFs have different resource requirements. We've talked about this already, but we need to be able to model that. If you're instantiating multiple VNFs, what is the total level of resources that are required? From an operator perspective, they may want to have 3 resources available so that they can upsell additional services to end users. There's the compatibility with the hardware. I talked about this already. This again has to be checked. Which acceleration mechanisms are being used? How are you actually getting communication to be established between the different VNFs? Is this fully compatible with the hardware that is available? I've talked already about the transition to Denverton, and that's posing some problems for certain VNF vendors as they need to upgrade their software to be able to cope with this new hardware environment. And some of the additions to the acceleration mechanisms that Intel and others are making available, for instance, multi-queue DPDK. There is also the performance of the VNF within the service chain. There may be some specific bottlenecks that are created that need troubleshooted. And this brings me to another point, which is, what are the troubleshooting tools available to pinpoint any specific performance issues or functional issues so that they can be isolated and then fed back to the vendors if necessary, to the NSD if you need to reconfigure the actual service chain. Talked already about VNFs being still relatively immature within the industry and are subject to quite frequent updates. We need to look at how that is actually affected from the controller. And then, of course, the controller to VNF communication, we need to look at what's available there. Is it just a REST API? Do we have granular availability of the individual features and functions with something like netconf? Or is it something completely different? And we saw one instance of a VNF where you needed a Windows application to be able to configure the specific features and functions of the VNF. So you're not very adapted to a multi-vendor UCP environment. So those are just some of the points that we need to go and look at. So when I go to my next slide, we can see some of the steps that we go through when we look at all of this. So first of all, we use a design tool to design the network service. We have a relatively easy drag and drop environment to be able to instantiate the VNFs, to allocate resources to them, to associate them with specific ports, WAN and LAN ports. We can also pin to specific CPU cores if required, and other configuration parameters. Then once that is all designed, then we publish the service to an orchestrator. Could be a third-party orchestrator or one provided by ourselves. Then part of that service definition is to allow the OSS BSS to pass specific customer-specific parameters to the VNF so that we can individualize it to the specific requirements of a customer or an individual site. Then in another step, we would then we would make the UCP available on site and instantiate the VNF. whereby the UCP itself would then retrieve its configuration from the orchestrator. So once that's done, we can instantiate the service. At that point, typically the VNF would contact a portal. It may be a vendor portal, or it may be the service provider cloud portal, to get different configuration information. And then at that point, the portal would register the VNF on the controller. At that point, the next step would be for the orchestrator to send the specific configuration to the controller, and then the controller in turn would configure the VNF. And then, of course, once the VNF has all of its configuration parameters, we hope, all being well, that the VNF is ready, goes green, and we have a live service. So all of this needs to be automated, as indicated here in the title, a zero-touch provisioning process, so that we have a seamless configuration instantiation from the customer portal when the end user selects the service that they require, and then all of this is then automatically passed through the system to the different components of the system, so that we have an up and running service. I think at this point we have another poll question, if I'm right.
Yep, that's right. I'll just click through to the next slide. Our question for the audience is, which of the following areas do you see as the most problematic for VNFs? So we're asking you here just to pick one. Obviously, they can all cause problems, but which one do you think is the biggest pain point? Is it manageability, scalability, functionality, chainability, upgradability, data plane performance, or this issue about getting different performance on different x86 generations? Just remind everybody that we are getting close to the audience Q&A time, so if you haven't done so already, please submit your questions. Let's see what people have voted for, Praveen. We can do an update in a few seconds, but it looks like there's a lot of options here to see on my screen. We've got, I'll just do a little update, see if we get a clearer response. So there's two most popular responses are manageability and data plane performance, but all of the options that have been chosen, as we said, they can all cause issues, but manageability and data plane performance are the two key ones. But would you say from your experience, Praveen, that those are also the key problem areas with VNFs?
No, I'd agree absolutely. Those are the two key things that really come to the fore. I mean, as you said, all of the others are important. But clearly when we look at a VNF, how can we manage it? It's probably the most important question in our mind. And I think certainly from our CSP customers, it is, what performance do I get? Which is related to the other question, which is, how many VNFs can I stuff into this UCPE, given the limited number of cores that I want to put on it in the first place?
Right. Okay, that takes us through to the organizational challenges. So moving beyond the technical aspects, SDN and NFV also gives us some challenges in terms of how we organize ourselves. Operators used to only have to concern themselves with networking technology, but now they need to reskill in things like virtualization, software management, perhaps even going as far as writing Yang models to describe their service offering. When problems arise with VNFs running on UCPE, the operator might struggle to identify the root cause. Is it the VNF? Is it the UCPE itself? Is it perhaps other VNFs or physical network functions in the same service chain that are causing the problem? Or is it some combination of all of these different potential sources? Pinpointing that can be a challenge, and it makes it a challenge to ensure resiliency to support the SLAs that your customer expects. So to avoid these problems, the temptation is always to over-provision the UCPE so that you don't get any sort of performance issues. But over-provisioning it with a lot of memory and a lot of processing power can make it unnecessarily expensive and potentially undermine the whole business case for NFV in the first place. Another challenge is the degree of control that operators are prepared to give their enterprise customers in terms of their ability to manage the device and the applications that are running on top. Now, some enterprise admins might want to make changes to firewall settings, for example, and if they have to go through their service provider to implement those, that's going to be hugely annoying. Large enterprises want to keep control of their security systems in particular, and if they're losing control through some sort of UCP-based deployment of security, then they're unlikely to see a lot of value in it. So wrapping up with conclusions, given that we have now split the hardware from the software, VNF providers have built generic applications that are not customized for the particular hardware that an operator has chosen for their universal CPE. And as I was just touching on, that can lead to a lot of finger pointing when things go wrong. Is it the VNF fault? Is it the UCP? Or is it perhaps some management layer issue above? Often there's no clear accountability about who's going to sort out the problem. What operators need is for someone to take ownership of the NFV deployment. That could be internal project managers. They could look to use external systems integrators, or a supplier who can work as a lead implementer, resolving issues within the ecosystem of all of the NFV suppliers, so the CPE itself, the VNFs that run on top, and perhaps even into the orchestration domain. These lead implementers could help with the VNF interoperability testing and the onboarding process. They can ensure that the VNFs work in the specific NFV environment that an operator has chosen. That's its specific combination of the computing infrastructure, the virtual infrastructure manager, the virtual network function manager that it's chosen, and the orchestrator that sits on top. So for successful NFV deployment, operators they should really be looking to partner with vendors that can provide perhaps some sort of systems integration capability. They'll also be needing to train more of their own staff in key technologies. They don't want to be entirely reliant upon suppliers, so they need to skill their workforce in areas such as Linux, virtualization, OpenStack perhaps, and various DevOps tooling solutions that are out there. To make the enterprise deployments as painless as possible, the operators should try to select a UCP vendor that can support a broad range of third-party VNFs. Perhaps they've already integrated or pre-tested with a number of your chosen or preferred VNF types. You should also get an agreement with that UCP vendor that includes terms for the support of new VNFs and new versions of existing VNFs. They'll all need testing, they'll all need evaluating, and not just in isolation, they'll all need testing in terms of their impact on a complete service chain. So those are some of the takeaways. As I say, this is all from an upcoming white paper that I've written on the topic of integration challenges of NFV, and particularly in the context of SD-WAN for enterprise services. So with that, we're going to move into the audience Q&A session. If you haven't done so already, please submit your questions via the widget at the bottom of your screens. And I'll start off with this one, Praveen. What type of hardware will be used for NFV? We mentioned specific hardware like, this question is getting a bit too big for my screen. You mentioned specific hardware like ASICs and FPGAs. They can be replaced by x86 CPUs. Is that always the case, or will FPGAs and ASICs still be used? And if so, in which cases? Well, I think in an enterprise networking setting, feasibly, you could have all of these different network functions that did previously run on devices using proprietary ASICs. You could run all of those feasibly on x86 CPUs. There might be some particular applications that are very resource hungry where the cost benefit might not make sense. You might need to have so many x86 processors that it wasn't cost effective versus an ASIC. But generally, I think for small, certainly for small and medium enterprise applications, x86 with all of these hardware acceleration technologies we talked about, it should be sufficient. In the operator, in the service provider's core network, their core routing infrastructure, that's unlikely to move to x86 for the foreseeable future, because those are very high throughput devices, and even these hardware acceleration techniques that we talked about aren't going to get anywhere near the cost performance capabilities of today's high-end core routers that are based on ASICs. But in an enterprise setting, I think there's more scope for these applications to be run on x86. Do you know, Praveen, in your experience, are there any particular enterprise networking functions that you're just finding are too resource hungry, that they can't be run on these sort of UCP platforms?
Yeah, I mean, I think two do come to mind. I mean, WAN optimization has often tried to use acceleration techniques that is quite resource heavy. But I think for me, the underlying direction of travel is not to use ASICs or FPGAs in a UCP environment or in a data center environment. The idea is to have the maximum flexibility and agility. I think what we see is that certain vendors would prefer to see specific ASICs used, and I won't mention any names, but I can see at least one of them is on here asking a question in that direction. Clearly they would prefer their appliance to be used, and it's got some specific acceleration technology in there, in the form of typically an ASIC. But I think the general direction of travel is to go away from that to get the agility and flexibility that is implied by a common compute platform where you can move VNFs around very quickly.
Okay, great. I'm going to push out onto everybody's screens a survey. It should pop up on a separate window, a separate tab rather in your browser. Now, this is just to get your feedback on the webinar, what you liked, what you didn't like, what sort of things you'd like us to cover in the future. And so if you are kind enough to fill that out, whilst you do, I'll go back to our audience questions, and let's have a look at this next one. This question is, do we see a lot of dedicated internet connections for SD-WAN, so DIA, dedicated internet access? I'll let Praveen comment on this, but I was at a conference recently, I think it's the same one that Praveen was at, and there was some data presented there by another analyst research firm, and showing the difference in price between MPLS and direct internet access, and clearly it's almost half the price per megabit per second, for example, of that direct internet access is half the price of MPLS. So there's a big cost saving, and that's why people are getting the benefit from SD-WAN, going to SD-WAN with direct internet access instead of paying for the perceived higher quality of MPLS. They're prepared to use direct internet access for perhaps less critical applications. They might offload some of the web browsing, for example, of their enterprise users. So my impression is that very much so that they are using direct internet access, but it does vary by geography. Each country has got different regulations, different competitive dynamics. I know that, for example, in my own country, in the UK, for whatever reason, there's not a huge difference in price between basic MPLS and direct internet access. Where you pay a premium is for a managed service, but the two basic connectivity types can both be purchased at relatively similar prices. But that does differ by country. In the US, the figures I was looking at earlier suggest that there is a big difference. But I'll hand over to Praveen. Praveen, have you seen much evidence of direct internet access being used for SD-WAN?
I think the short answer is yes. That's almost one of the underlying drivers to use SD-WAN. But I think there's a couple of nuances here. The pickup for SD-WAN has been principally driven by large enterprise customers with a multinational footprint. And often those large enterprises find that they have extremely expensive MPLS connections in certain parts of the world. Like you, I saw a recent presentation where one end user claims just suppressing one MPLS link paid for his whole SD-WAN solution, which was an interesting observation. But I think it's also correct there are many regions around the world where that's not the case. So, if you look at the Nordics, if you look at Italy, you mentioned the UK, the price difference is not that great. Although one has to be a little bit careful here because there's residential grade direct internet access and there's business grade. So quite often the residential grade direct internet access is really quite cheap. Whereas if you want an SLA, a sort of business grade internet connection, which I think is what most enterprises are preferring when they're building SD-WAN solutions, then quite often the price difference is not that much.
Yeah, exactly. So the term I think I would tend to use for the lower grade access is just broadband. That's the consumer product, but direct internet access assumes some sort of SLA, and with it goes a higher price. Okay, I think we've got time for maybe one or two more. Question here is, do you think that a large NFV deployment is feasible or practical without an NFV orchestrated solution sitting on top? Oh, I think we might have lost Praveen there.
I think I'm still here.
Becky, are we? Oh, you're still there. We might have lost. We've got some interesting music. Okay, it's cut out. Good. So the question, Praveen, was: Do you think that a large NFV deployment is feasible without some sort of orchestrator solution sitting on top? So obviously, when we were showing the UCP architecture, we were talking about the specific device and the software and the middleware that runs on that. But in the deployments that you've been involved in, is there a northbound orchestrator that is communicating with that device, or how is it managed?
Well, I think we see it's either REST or netconf seems to be the two preferred methodologies. There's some interest in RESTconf that can replicate the transactional elements of netconf using a REST API. I still think that's fairly immature in terms of deployment. So I do believe that fairly large NFV deployments are possible. There are a number of solid orchestration options out there. But I do also think that there's a lot of, it's not so much the orchestrator that is the problem, it's more the maturity of the VNFs themselves. So if you can find a VNF that can talk easily to an orchestrator that has a good API, be it netconf or REST, then I think that's absolutely feasible. I think the second half of the question about closed loop automation, yes, I think to get huge scale, that's probably important, but I think it's more a question of reducing costs as opposed to underlying feasibility would be my response to that.
Okay, great. I think that's pretty much all the time we're going to have for questions. There are several more that are in in the platform there that we'll have to ask you to follow up by email, Praveen, because we're getting close to the top of the hour. So I'd like to just thank Praveen Mirchandani from Equinox for his presentation today. Thank the audience, of course, for your participation. And I'll leave it to you to say goodbye, Praveen.
Well, thank you very much. I hope you enjoyed that, and I hope you learned some of the integration challenges that we face. We are heavily involved in this, working with multiple service providers around the world to help them deliver this. And we believe that we've built up a considerable body now of expertise in doing this and working with multiple VNF vendors and multiple orchestrators. So on that note, I thank you very much for your attention.
Thank you.